Very good morning. Today we are going to see a problem on transformer to calculate its efficiency and also to draw that resultant circuit. That means equivalent circuit we are drawing. Take down this problem. A 50 kVA 2200 bar 110 volts. That means primary side is 2200 volts and the secondary side is 110 volts. Transformer when tested gave the following results. First in OC test, that means on LV side it is 400 watts, comma 10 amperes, comma 110. In the SC's test, that means on the HV side 808 watts, 20.5 amperes, 90 volts. Compute all the parameters of equivalent circuit referred to the HV side and draw the resultant circuit. That means equivalent circuit. So in the OC test, the open circuit test, the iron losses we got it as 400 watts. In short circuit test, copper losses we got it as 808 watts. So the copper losses are the short circuit from the short circuit test WSC. Okay, WSC is equal to ISC squared into R naught. So here from this R naught 1 is equal to WSC divided by ISC squared. That means P is equal to I squared R. So R is equal to P divided by I squared. So WSC is what? WSC is 808 divided by ISC. ISC in short circuit 20.5 amperes whole square. So R naught 1 is equal to 1.92 ohms. Now we are going to find out impedance Z naught. So resistance component we have found out. Impedance Z naught 1 is equal to V is equal to I into Z. Z is equal to V divided by I. So VSC divided by ISC. Okay, VSC divided by ISC. So VSC is what? VSC is 90 divided by ISC is 20.5. So if you simplify, you get Z naught 1 as 4.39. Now X naught 1. So reactance X naught 1 is equal to square root of Z naught 1 squared minus R naught 1 squared. So Z naught 1 we calculated as 4.39 minus R naught 1 we calculated as 1.92. So if you simplify this with your scientific calculator, we got the answer X naught 1 as 3.94. Now WOC. Okay, WOC, that means open circuit loss. Open circuit loss equal to VOC into IOC into cos phi. So from that easily we can find out cos phi because we know WOC, that is open circuit power loss. VOC we know. From that easily we can find out the cos phi. So WOC from the question. It is given as open circuit power loss. It is given as that means current law. Iron loss. Iron loss we got it as 400 watts. So 400 that we are substituting WOC. VOC 110 volts that is given in the problem. VOC is 110 volts. And similarly IOC is 10 ohms. Sorry, 10 amperes. 10 amperes that is also given in the. So here cos phi naught we can easily calculate. So cos phi naught is equal to 0.36. So phi naught is equal to cos inverse of 0.36 is 69.89 degrees. Now we are also finding out sin phi naught also. So sin phi naught we got it as 0.93. Okay. Now we need to calculate magnetizing current and as well as working component current. So magnetizing current I mu is equal to, in some books it is mentioned as IM or I mu. So whatever the notation you use, you can use I mu is equal to I naught IOC, that is open circuit current into sin phi. So open circuit current in the problem, from the problem open circuit current is 10 amperes. So 10 amperes into, okay, so 10 amperes into sin phi. Sin phi naught we calculate as 0.93. So 0.93 we calculate. So that if you further simplify, we got the answer as 9.3 amperes. That is magnetizing current. Now working component current. That means IW is equal to IOC into cos phi naught. So IOC is in base. Cos phi naught is already been calculated. It is 0.36. So cos phi naught 0.36. If you substitute, we got the answer for working component as 3.6 amperes. Now, core loss resistance. Core loss resistance R naught also we are going to calculate. R naught is equal to VOC divided by IW. So VOC is what? 110 volts. So VOC given in the problem as VOC given in the problem as 110 volts divided by IW, working component 3.6. So for the simplification, we got R naught as 30.5. Now, magnetizing reactance X naught is equal to VOC divided by I mu. Okay, magnetizing reactance. That means here R naught and X naught. Working component that R naught and X naught. X naught is magnetizing reactance. So this is core loss resistance. Okay, core loss resistance. That also here we are finding. So X naught is equal to VOC divided by I mu or Im. So VOC 110 divided by I mu, we already calculated as 9.3. So we are substituting 9.3. Further simplification, we got the magnetizing reactance as 11.82. Now we are drawing the equivalent circuit of the transformer referred to HV side, that means primary, because HV side is primary. The problem HV side is primary. So the problem what they given is draw the resultant circuit referred to HV side, like that clearly given. So we are drawing with the referred to primary side. So primary side means all we have to take this to left side. That means primary side. So R01, X01 that I am mentioning. So here it is V1. V1 is given in the problem is 2200. Okay, 2200 volts. 2200 volts given in the problem. Now here it is R0. So R01 we calculated as 1.92 ohms. Next is X01 we calculated as 3.94 ohms. So R01 1.92 ohms, X01 3.94 ohms. Now this core loss resistance and as well as magnetizing resistance, that means R0 and X0. So the current flowing through here is IW. So IW is 3.6 amperes. Next is this point. This is magnetizing reactance. The current flowing through magnetizing reactance is I mu or Im is equal to 9.3 amperes that we calculate. Okay, so this is all mentioned. Now this side, that means V2 dash, because all we are referred to second primary, so V2 dash equal to V2 divided by. So this is the equivalent circuit of the transformer referred to HV side. That means in the primary side.